So, my name's Clay Caviness. I work for Google as a site reliability engineer. We manage an absurdly large number of Macs. Last we looked the other day, it was a little bit over 81,000 30-day actives, which is bananas to me. I don't understand how that ever happened. I could give you a precise number, but not an accurate number, so we'll just stay with around 81,000. I'm going to talk about a few methods you can use to secure some of your management tools, because as we all know, users do pretty terrible things. So, a foolish man that I know pretty well once said, if a user repeatedly disables your management tools, you no longer have a technical problem, you have a personnel problem. Because at a certain point, you're not dealing with a user, you're dealing with a malicious actor. They're doing this, on their own. And all of the technical roadblocks in the world won't stop them. At this time, it's time to deal with them with management or HR, or if you have to, the authorities, however you need to do that. Just remember though, Hanlon's razor, if you don't know this, which they're probably just trying to get their jobs done is the point, basically. They're more than likely, they're not being malicious, they just want some tool or update or something like that that they need. Or they're just trying to do some other non-work related thing it's totally fine, not any problem. Or maybe they're actually installing the totally legitimate torrent program just to download the latest Game of Thrones, but that's probably not good. But everything else is all right. I'll give you a quick overview of what we do at Google. If you were here last year, I went over this in more detail, and I'd be glad to answer any questions as well about this later. Configuration management. We use Puppet in standalone or masterless mode. Puppet, it's all Ruby. We have a wrapper script that's written in Python that does all the standalone downloads of the packages and verifies the signatures and things like that. We use Monkey for package deployments. Everyone here, I'm sure, knows Monkey. That's in Python. We have a bunch of random inventory and logging, log collection, security, all sorts of tools like that. Those run as well. Most of those are in either Python or they're compiled Objective-C or Go binaries. Since we don't hate ourselves, the only Ruby that we actually deal with is inside of Puppet and Factor. All of the compiled binaries, the ones that are in Go and Objective-C and so on, those tend to be fairly robust. If a compiled Objective-C binary is not able to run on your system, you probably have larger problems than your management tool is not working. We don't do anything that complicated in shell, really. A good rule of thumb that we try to do internally is if your shell script is more than 25 lines, it should probably stop being a shell script. So we have all these interpreted language scripts, all using these various shebang lines. So you probably all know this as well, but it's just the common way you pronounce the pound exclamation point at the beginning of a script. So when a script is run as an executable, which most of our management tools are, scripts of some sort, the program loader just runs the interpreter that's after the hash bang at the beginning and gives this path of the script itself as an argument. You can control this shebang any way you want. It just has to be a valid executable. Some of the ways we've seen common ones, the shell scripts, Python, Ruby. The bin-env Python just means look up Python in the environment, which is find the first one in the path, which is usually okay, but you can run into a lot of issues with that. I'll cover one we found that was kind of bizarre. So all these scripts have their various shebang lines, and you're wondering, how do these get messed up? Well, there are many, many, many ways we have seen. 81,000 people, a lot of them are very smart engineers, and they know how to, they used to be former Apple developers, they were sysadmins at their last job, so they do all sorts of crazy things. They just want to try to get their work done. So, PyObc. It's a Python Objective-C bridge. Greg Nagel, I think, is talking about this tomorrow, right next door, 10:15. Apple ships version 2.5 of the PyObc bridge. The latest version is 3.2, has a lot of new features and new bug fixes and things like that. Of course, our intrepid user just wants to use the latest PyObc, so she's a Mac developer, why not? What's the harm in that? So, pip install PyObc, everything's fine, right? Well, in PyOpsy version 3 and later, you have to use the PyOpsy's super method, not the one that's built into Python. Otherwise, things can break in strange ways that you don't quite understand at first. Most of the programs that use PyOpsy, that use this call have since been fixed. This was from about a year and a half ago. Like Monkey and CrankD and things like that. But the underlying issue of people upgrading pre-installed modules to strange effect is still there. So Python 3, that's not shipped with OS 10, Mac OS, but it's new and fancy. So back in the old days, we had someone install Python 3, and then they clobbered user bin Python and made it point to Python 3. And of course, everything that called user bin Python that was written in Python 2 would break in strange and fascinating ways. Yeah, it's terrible. Again, I mean, you could sort of avoid this back before SIP by pointing to user bin Python 2.7 directly to that. Hopefully they're not going to clobber that one and call that one Python 3. That's kind of bordering on malicious, but who knows. This is the convoluted one I saw. We had someone install Python 3 out of, I think, Homebrew or MacPorts. And then they made the system path have their version of Python 3 named Python ahead of user bin. So anything anything used in Python would end up loading up Python 3. I don't know why they thought this was the way to do it. They just wanted the hammer. They wanted their home Python to be the local one. But 81,000 users, you're going to find all sorts of strange things that people will do. Same sort of thing with Ruby. Version 2.0 was what ships with macOS. It was marked end of life last year. No, almost a year ago, a while ago. Version 2.4 is the latest. Of course, they want to run the latest thing. Well, if you use Puppet 3 will not work with Ruby 2.2 or later. You have to use Ruby 2.0 or 2.1. Puppet 3, of course, is fairly old. It was just end of life actually in December. So you probably upgraded to Puppet 4 if you use Puppets, but of course Puppet 4 won't work with Ruby 2.0, so you have to have installed Ruby 2.1 at some point, so there's a very mix of insanity going on there. Most of these have been mitigated since system integrity protection has been put in place. That'll stop people from easily clobbering the user bin, the Apple controlled locations on disk. But of course, there's still reasons you might want to disable SIP for either development purposes or other reasons. So you need to sort of figure out a way around these sort of problems. We've seen other strange things show up. Had a malformed Python egg, which is a way to ship modules, Python modules out. We had one of those in the system path that caused Python to crash when it was being loaded. We had all sorts of strange damage that users did to the system Python framework and the Ruby frameworks. We had someone delete the entire system library Python framework and the Ruby frameworks. They just wanted space, I think. It was strange. I don't know why. Just like they're trying to delete chess app. I'm like, I don't want chess, but I'll delete the whole Python. I don't know. Anyway. Also, we have just random strange support tickets that, they want to Puppet comes with viruses, so please don't. And I mean, so first you're like, initial reaction. Wait, what did I just read? That can't be. And then you don't even know how to reply, right? It's and root users. I don't know. So what can we do? It's covered a little bit today. Many of you don't give users admin rights, perhaps, but you may have changed your policy since Sam's talk earlier this morning, where he said admin rights are totally fine. At Google, actually, most users have admin rights, so I guess we were ahead of the curve there. Just never got past it to get behind it. So no admin access plus 10.11 SIP really restricts the attack surface and the issues that you might have. But of course, as we saw with Sam and other people, it's not a panacea. So if they have physical access to the machine, which they probably do, it's their machine, physical access is the moral equivalent of admin access. Once you have a determined attacker with physical access to the machine can almost always get admin access and full access. like I said, Sam mentioned some of these before. If you haven't, read up on the firmware exploits like Trammell Hudson's Thunderstrike from a few years ago, or the EFI exploit that Sam was just showing as well. So read up on it if you want to lose all hope, because between that EFI stuff and all the things that Papine was talking about, it's easy just to give up, right? But also remember Hanlon's razor. Your users are probably not trying to be bad. They're just trying to do something they want to do. It's best not to think about it too much, about all the ways that security can mess you up. If you spend time talking to a security engineer, Papine will probably back me up. The only provably secure computer is one that's been powered off, pulverized, encased in concrete, and then launched out of the solar system. Not very useful, but it's absolutely secure. They'll also tell you that you can never win. You're always going to lose security, but you just keep trying and just build up as you can. It's layers, like onions or ogres. So I do have a few suggestions. These are some of the things we tried. These are not the things you should try. These are things that were weird and kind of worked back in the day, and we were kind of hacking it together because that's what you do. And when 10.8 was the thing. We were just basically installing, we were making sure that the user bin Python file was always a symlink to the actual Python 2.7 binary that's inside the frameworks. Obviously, that's not SIP compliant, and 10.11 came along, and that doesn't work anymore. And this fixed, someone installed Python and it clobbered user bin Python, but things will still break, and we don't want to have to fight against the user all the time. We also packaged up the entire system Python and Ruby frameworks for a while, just because we thought, well, let's try this. And we have a script that the support people can use. They can run the script, it'll reinstall the framework, so everything gets back, it's all good. But as you could probably imagine, this is very fragile. It falls apart a lot during minor updates, can frequently make incompatible changes. SIP obviously makes this kind of moot with since 10.11, 10.12. And of course, again, you're still not all protected because a lot of the other problems I mentioned earlier can still crop up, plus many others that that you'll discover on your own. So this is what we finally did. Basically compiled our own Python, our own Ruby, and then we installed them someplace else that's like a non-standard location. This is great. We can control what version of Python is installed, what version of Ruby is installed, and we'll update them much more quickly than Apple ever will, which I'll come to in a minute. So a brief aside on OpenSSL. So you can look this phrase up in your favorite search engine. So Marco is a fairly well-known open source developer on, I think, OpenBSD and some other things like that. He was looking into OpenSSL many years ago. The write-up there it's fascinating and frankly terrifying look into the internals of OpenSSL and how it's designed and laid out. It's insane. You'll probably be amazed after reading this that anything involving OpenSSL actually works. Well, Apple, they thought OpenSSL is terrible, we'll write our own. They moved away from OpenSSL, as they should, and they wrote their own secure transport layer. Obviously, this has not been without its own set of amazing bugs. Writing cryptographic software is very, very hard. Obviously, this is a pretty simple bug, but it's still terrifying. Let's just skip over everything else. It's fine. This is from the Transmitting Data Securely section of the Apple Cryptographic Services Guide. So basically, Apple's stance on OpenSSL is don't use OpenSSL, and if you must, include your own, and you're responsible for it all. They basically gave up. But of course, they shipped Python and Ruby. Python and Ruby still use OpenSSL, you can see, and this is in Sierra just recently. So OpenSSL 1.1.0 is the latest version. Most people are probably still in the 1.02 branch, which is the long-term support branch. But if you take a closer look at what Apple ships with Sierra, they're not even using the same out-of-date version of Python. Anyway, I have the same reactions I have to that support ticket. I'm like, how do they? But we're engineers, so we can fix this. Your tools talk to network servers, so having good network transport security is very important. So using old OpenSSL, unpatched OpenSSL, not too good. So my colleague, Anthony Vicharushny, I try to pronounce his name, he just left the team, unfortunately. He created a luggage recipe for configuring and compiling the latest OpenSSL from source. I can wait if you guys want to. I'm kidding. It's there. All of this code is on our GitHub site, and or linked to other GitHub sites, repositories. So this and all the recipes I'm posting about, they're more of a framework of what to do. Obviously, you're going to need to change them for your own internal use and adjust it for your own needs. So now that we have the OpenSSL built, brand new, latest version, whatever version we want to use, that's latest, up-to-date, fully patched, obviously very secure, maybe not written by monkeys, who knows. It's pretty simple to build Ruby. You just point it at the custom OpenSSL that you've just installed and build away. The only kind of tricky bit it took a minute to figure out was the enable load relative flag to when you're configuring it. That just allows the installed location of Ruby to be different from where you built it. So move the whole thing around. Obviously, if you're using package creation tool like the luggage, which you may or may not, it's makefile, so it's kind of weird. That'll build it all in like temp the luggage some path, but you want to install it into, in this case, I made up library megacorp support. We don't actually use that. We use a different name. People thought that. I'm like, no, we don't call ourselves megacorp. That was just, yeah. Anyway, Python was a little more complex. Again, all of this is in the GitHub. We had to be a little more clever to make sure we were telling it to use the OpenSSL that we just built and installed. We also added a small patch to ssl.py to logs data of every certificate it sees. That was really made our security team very happy. That way, any cert that Python ever encounters and goes through that module, it gets logged, and then they can go back later for science and see what happened. There were a few more steps. So we looked at Apple's open source builds tools to see how they actually built. If you look at the Apple open source releases, you can see how they're actually building Python and see what patches that they're applying. It turns out they use .ed files to do a lot of patching, which that's an ed file. That's a file with a bunch of ed commands. I mean, it's Apple, but some really old school Unix people working for them. I guess that was, I don't know, clever. I mean, it is in a way, but they look like this. So when you're trying to figure out how to patch the newest version of Python with these .ed files, what you do, if you're me, is you pull them down and you try to apply them locally, and then you see what breaks, and obviously they just fail without really much output. Then you spend some time looking on the internet with your favorite search engine, and you see that you can put a capital H at the top of a .ed file, and that'll give you a little bit of more output, at least telling you what line it's failing on, or a little bit of output of error output. So then you try to remember how ed works and what are all these strange commands and what it's actually trying to do. Turns out that most of the things that break when you try to patch in a newer version of Python with the older patches from Apple are things that have already been fixed upstream. So like Apple has made a change, they've submitted upstream, but they're still using the older version internally. Ed, by the way, has the best user interface ever designed. Control D, by the way, will get you out of Ed. Or I guess Control / if you want to core dump and get out of it really badly, or just restart the computer. I guess it's fine. I really like Eat Flaming Death. That's kind of how you feel after like, what again? So obviously a lot of distractions trying to get all this stuff done. So we have custom Python built against a custom OpenSSL. So there's virtual env, which is a tool you can use to create a completely standalone Python environment. Normally it's used to take your system Python or your current Python and build a standalone one that a lot of Python web developers actually use. It'll also bundle in any libraries and frameworks that you might need as well. Pretty well-known tool amongst Python developers, but again, I'm not sure how common that would be with everyone here. So obviously this is a little bit of belt and suspenders work, because if you're following along, and hopefully you are because you're here, we built OpenSSL, installed it, we built custom Python pointing to the new OpenSSL, and then we installed that. And now we're using virtual env on the custom Python to make a new Python and installing that with these extra tools. Sort of a lot going on, but disk space is cheap, so it was probably fine. I think in the end we'd probably, if I had some time, I would just make the Python env package not include the rest of the Python, but it's fine. Since we like all of our builds to be repeatable and not have any external dependencies, there's a tool called pip2py. It recreates the directory structure that pip, which is the package management tool that Python uses, creates the whole thing locally. And this way we can cache all of the various Python modules that we want to use internally, like xadder, PyOpenSSL, PyOpc, things like that. Some things that aren't with the built-in system, don't come with upstream Python, but are installed by default on the Apple Python. I'm putting it all together. We have all these new custom Python, custom Ruby. Well, you just change the shebang lang everywhere. You just point it at whatever script it is. Pretty easy. I mean, just do it all at once. If you do everything at once, you can sort of yank the tablecloth out and everything stays. Probably not that way. This makes you nervous. It's okay. I mean, what we did, we basically put the new interpreters out everywhere we could. We had it on our imaging when we were doing imaging. Our provisioning script made sure it was installed. Puppet was installing it. We were using Monkey to push it out. planb was also ensuring everything was installed. Once we were sure everything was out there, we're fairly confident. We took some relatively minor management tool that used Python, and we changed it to use the new location of Python. Rolled that out. We deployed it slowly. We monitored things as it came through. We did one more of them, and then we sort of did them all. The same sort of method: do a little bit at a time, roll it out slowly, watch how things happen. I mentioned planb. So this is a remediation program for managed Macs, released a couple years ago. It's meant to be run to reinstall all the other management software that you might have. It's an Objective-C program, self-contained. There's no external dependencies. Like I mentioned before, if a compiled Objective-C program is not running on your systems, you're probably having larger issues. It'll still run, obviously, if the Python and Ruby frameworks that you've installed are completely broken somehow. It's a pretty simple model. Just fetches a given list of disk images from a server, and the list of disk images in the server itself are actually compiled into the binary, so there's no external source of truth there. Everything's self-contained, so you build planb, you code sign it, you know that it's always going to be pulling from the correct source. It does strong SSL client and server validation, and then installs these disk images. Pretty easy. Install Python, install Ruby, install Puppet. Just go down the list of the things that you want to install. If you're using some other management tools, you can still use this. If it's not open source, reinstall Jamf. Do whatever you want. Every hour, we have a launchd job that runs a 130-line shell script, so I'm sorry, I don't take my own advice. That actually checks the management tools and makes sure that they have run successfully in the last few days. So every time our management tools run, they make a little, they touch a little flag file somewhere in /var that, hey, everything was good, I ran successfully. With the script just checks that that's within a certain threshold of days old. And if it's not, fire off a whole planb run, reinstalls everything should come right back up. If it doesn't, you've probably run into yet another edge case that you haven't thought about, or there's something else that's going on, but you're monitoring and logging everything, so hopefully you'll be able to figure this out over time. So we also try to do all of our management tools to be as self-repairing as possible. This is good, especially if you're using open source tools and writing your own stuff. Obviously, if the interpreter is broken, there's nothing to be done except a planb run or some other remediation like that. But for an example, our Puppet install, which is Ruby, if you might remember, is controlled by a Python script. Well, the Python script checks that Ruby is working first before it even tries to run Puppet. If it's not working correctly, it runs planb. It also makes sure that Monkey is installed and running. Monkey, we have Monkey making sure that Puppet is installed and running. things like that. It's like I mentioned before, layers of security, like ogres. Obviously, there's still things that users can do. I mean, your monitoring should catch all of this if things are really going completely off the rails and everything's broken. Maybe you can automate things, and if a machine stops checking in, you revoke their access to companies' resources. This is what we're moving towards pretty quickly at Google. It's the zero trust sort of beyond corp model. I mean, the key quote here is, assume that the internal network is as dangerous as a public internet. The old, I have a nice firewall around my company's internets, and if I connect to the internet, I have, passwordless access to the databases or something. Don't do that. That's not going to work, because that's like the old medieval forts. If you can get through the wall, nice, soft, chewy interior of peasants to go through. It's not good. And of course, I should say that with this model, we have the idea is you have a relatively easy to acquire a certificate, a client certificate, but that really doesn't give you anything. That's more like a serial number. And then the machines themselves, the endpoints, report up through the management tools, their own patch level, how making sure all of the tools are running, all of the logs have been successfully updated, things like that. Once we know that it's in our inventory system, the management tools are running successfully, everything like that, then we can give it more and more trust as you go. And if they stop checking in, then you can revoke their trust or just put their trust down to the minimal level where all they can do is talk to the internet or talk to your management services. And then hopefully that'll kind of work. Just remember though, from at the beginning, at a certain point, things stop being engineering problems and they start being policy and personnel problems. So you have to know there's a level you're not going to be able to fix things with a technical solution everywhere. I'll leave you with this quote, which is what my wife said when I described this talk to her. I was like, it's a little bit more complicated than that. I mean, there's code snippets, and I mean, it's not just, I guess it is, but hope this is interesting. If you have any feedback or questions or anything like that, like I said, this was going to be a little bit shorter than the other ones. Hopefully everyone else was a little bit long, but I'll give you some extra time. You can have more coffee. This is all the contact information, and if you have any questions about this or anything else, I'd be happy to answer or try to answer.
Any questions? No?
Okay.
Did you change Monkey to use your own compiled version of Python?
Did we change Monkey to use our own compiled? Yes, we did. We use our own custom Python everywhere. Anywhere that uses Python, we've changed it. Yes?
So, tailing on that, did that require you to actually do any rewriting in Monkey? I mean, do you have like your own, or did it just kind of work?
It just works. I think there's a tweak in the build already. But yeah, it works right out of the box. I think there's a few of the tool scripts we never changed. I think maybe like make package info or something might still use the built-in Python, but that's like not an end user tool, so we're less concerned about that. Yeah, we did have to change we do have to patch the Managed Software Center's .m file somewhere. That's the only thing we had to patch in to use our Python and not the system Python. I think everything else just worked. Yes?
I have one of those question statements, but it's real short, about OpenSSL overlay.
Yes.
Apple actually still uses that. If you install Active Directory profiles, it shells out to OpenSSL.
If you install Active Directory, Apple still shells out to OpenSSL 098?
Yeah.
That's fantastic. Yeah. And like I said before, they're not even with Ruby and Python that they ship, it's two different versions of OpenSSL that they're compiled against, so they can't even be internally consistent, which I guess I'm not surprised about. They obviously don't care. Anything else? Yes?
Where do you actually stick your custom Python? In library?
Yeah, we just a library, Google Corp support or something like that. Basically, similar to what's up there, right? We just picked a spot that seemed unlikely to get clobbered randomly. I mean, if you do, user local seems tempting, but people do homebrew and that changes user local to be owned by the user all the time, and that's terrible, so we don't like that. So we'd find, a spot. We still, for some of the management tools, we put, we install them all in the library directory, but we have symlinks and user bin, or user local bin, so that, either running the updater scripts or whatever, the management tools, they can run those without having to like type the long path. It's just, symlinked into the installed one. Yes?
Do you try and set open firmware passwords to prevent users from disabling SIP, or if users are disabling SIP, is that now an HR problem?
Do we set passwords to disable SIP, or do we just? Well, we just track it. Right now, we're not doing. We're beginning to do a little bit of testing with firmware passwords because of the crazy AFI stuff that's coming out lately. But that's not being rolled out yet. It's just sort of, we're checking it out. It's a pretty complicated situation with 80,000 mostly laptops floating around the world. But SIP, we just monitor the current state of CSR util, look at the status of things, and if it's completely disabled, we follow up with the user like, you probably shouldn't be completely disabled. What do you really need? There's probably just one part of SIP you wanted to disable for whatever reason. Maybe they're a kernel developer or something like that. So we just sort of track that and monitor it. And if they, right now, our tooling is if they have it completely disabled, I think we just re-enable it and say hopefully they can come and figure out why things broke again.